Hello, my name is Adriane Chapman. I'm here with my colleague, Pamela Ugwudike, and we are here to talk about a data-driven analysis of the interplay between criminological theory and predictive policing algorithms. I'd like to hand it over to Pam to start with the criminological theory.
Thank you very much, Age. Now, one of the things we considered in our study was the impact of the theory that guides the design of a predictive policing algorithm. One of the theories we looked at was a near repeat thesis, which is a theory that holds that a crime incident would normally trigger a temporary increase in crime in nearby areas shortly after the initial incident if there are no measures like police patrols in place to deter potential offenders. We also investigated how the predictive models are response to another criminological theory, which is known as positivism or positivist criminology. And, positivism generally holds that, crime is a result of factors beyond the offender's control, such as sociological factors like poverty and long-term unemployment, psychological issues, or biological problems. So we compared how the predictive model we selected responds to both theories. The near repeat thesis sort of implies that crimes are random, non-random, and follows a specific pattern across time and space, while positivist theories imply that crimes are non-random and caused by factors beyond the offender's control. So to test how the model responds to both theories, we created a computational model that replicates the algorithm we selected. And I'll now hand over to Age to talk about methodology and findings.
Thank you. So once we had this model, next slide, please. Yep. Once we had this model, we created many different data sets. So the first data set we created was to mimic the near repeat thesis, in which crime was related geospatially and temporally. That is, once a crime happens, it's more likely to happen in that given area. The second data set that we created mimicked the positivist theory. That is, that crime is effectively random and it has no relationship geospatially or temporally. The third data set that we created was based on real data from the Kent police force through the UK's crime API. Once we had these data sets, we did some analysis about how often crime is actually reported by police by doing an analysis across hospital data, a crime survey, and looking at the police data itself. Once we had this, our results were very interesting. We ran each of the data sets through the algorithm, and the results of that were that the model itself, Pam, next slide, please. The model itself can introduce bias. So here we have both the near repeat thesis and the alternative thesis on day one, in which there is crime, it is effectively randomly distributed, and police are sent in a very random, completely distributed, no pattern manner. However, by day 48 in the near repeat, as expected, because crime is clustered in location and time, you see a separation of where we are sending police. Unfortunately, on day 48 of the alternative thesis, in completely random data, we're seeing effectively the same results. Pam, back to you for the conclusions.
Thank you, Age. And just to conclude, I want to say something about a key achievement of our study, which is that we've produced a robust computational framework for studying biases that may be inherent in predictive policing algorithms. Now, our framework is available on GitHub for researchers and others who may want to use it to test other predictive policing models to identify potential conduits of bias. As I said, most studies of predictive policing algorithms have focused mainly on how data sets impact on predictions, but our study also highlights the importance of reflecting on the theory or the assumptions that guide algorithm design. And this brings us to the end of this recording. Thank you very much for listening.